Consider the curve f of x equals x squared minus 4x minus 12. Determine the equation of the normal line to the curve when x equals 4. So the first thing we need to do is calculate the derivative of f of x, which gives us the gradient of any point on the curve. So the derivative is going to be represented as f dashed of x. And we can use our power out the front, one off the power rule, to derive each of these terms. So it's going to become 2x minus 4, and that's going to be the equation of the derivative function. And now we can use this rule to work out the gradient of a tangent to the point at x equals 4. So the gradient of the tangent is equal to the derivative evaluated at 4. And when we put 4 into that rule, we have 2 times 4 subtract 4, which is equal to 8 subtract 4 is 4. However, we need the gradient of the normal, so we need to remember that the gradient of the normal is perpendicular to the gradient of the tangent, which means we can calculate it by evaluating -1 divided by the gradient of the tangent. So that's going to equal -1 divided by 4. To find the equation of a normal line, we also need to know a point that it goes through. So we know that the x value is 4, so we also need to find the y value. So that means that f of 4 is the y value, and that is equal to 4 squared minus 4 times 4 minus 12. And if you evaluate that, it would be 16 subtract 16, which gives 0 overall, minus 12. So f of 4 is simply equal to minus 12. Therefore, we know that the gradient of the normal line is equal to -1 divided by 4, and that was back up here. And we also know that it passes through the point 4, -12. So because we have the gradient and a point that a line passes through, we can use the formula y take y1 equals m, the gradient, times x take x1. And now substituting in what we know, it's going to be y subtract -12, because that's the y1 value, is equal to the gradient, which is -1 divided by 4, times x subtract x1, which is positive 4. And now if we simplify that, that's going to be y plus 12 is equal to -x divided by 4, and then -1/4 times -4 is going to be plus 1. And then we're going to solve for y by subtracting 12 from both sides of the equation. And that will give us the equation y is equal to -x divided by 4 minus 11. And that is the equation of the normal to the curve f of x when x equals 4. On the CAS calculator, go into the main menu. Next, what we want to do is type in the equation that describes the curve f of x. So that was x to the power of 2 minus 4x minus 12. And now what we want to do is calculate the equation of a normal line. So we can highlight that expression and go interactive calculation line, and then we want a normal, so we click normal, and that gives us the expression for f of x. And the x value, where we want the normal line to be calculated, is at x equals 4. So we'll put 4 in there and press OK. And that tells us that the normal to the curve f of x at x equals 4 has the equation -x divided by 4 minus 11, which is the same as what we found by hand earlier. What we'll also do in this video is quickly have a look at the graph of this. So if we drag x squared minus 4x minus 12 down into the graph screen, and we quickly resize it by pressing this button, we'll change it to be from -10 to 10, and then y minimum of -20 until 10, and that should give us a nice view of this parabola. We can go analysis, sketch, normal, and by clicking 4 on the hard keypad, that will sketch the normal line at x equals 4. Hitting the blue execute key will give us the equation of that normal line, which is written down the bottom of the screen. So it is y equals -0.25x minus 11, which is the same as what we found in the main menu, and it's also the same as what we found by hand previously.